Good evening, guys. So today I'm going to discuss about the capacitor and its principle. So capacitor basically is an arrangement for storing large amount of electric surge, and hence it is called electrical energy storage. Okay. So capacitor consists of a system of two conductors. So you can see here this is a conductor A and conductor B. Okay. So two insulating plate, this there A and B. Now if you give some surge to insulating plate A by some battery terminal, then it will get the positive surge till it get the maximum potential energy. Then you have to bring a different insulating plate, that is called B. Then what will happen, due to some induced surge are generated in this side of the B plate and positive surge along this side. Okay, so this is the induced surge. Now this negative charge always try to reduce the potential of A, and positive charge always try to increase the potential A. But the most important thing is that the negative charge are more close towards the A, so therefore the overall the potential of A will decrease. So if potential decrease, so that means you have to supply some more surge to increase the potential. So that means the capacity of A increases. Okay, now let's take the second condition. If I connect this insulating B plate to the ground, then what will happen, the positive charge will flow through this ground. Okay, so then what will happen, then only negative charge remain on the plate. That means it will now further reduce the potential, because now positive charges are not present in the B plate. So therefore you have to supply more surge to increase the potential of A. So that means the capacitance of A is increases. So in this way we can increase the capacitance of a capacitor. So now there are various type of capacitors are there, that is called parallel plate capacitor. One is cylindrical, then spherical. All these things we will discuss later on. Now let's take the example of parallel plate capacitor. So here you can see there are two conductors, insulating conductors. Okay, the plate 1 and 2. So same, the negative charge are produced by some induced method, and that is grounded, so that positive charge are transferred to the earth. Now what will happen, it has positive charge, it has negative charge, so the charge density is sigma, and here charge density is minus sigma. Now if its area of this plate is capital A, then what will happen, the sigma can be written as, so you know that how can we write the sigma, that is, okay, so Q by A for the first surface, and similarly for the second surface. Again, if you consider the magnitude, then Q by A. Okay, although it is a negative charge, but if you consider the magnitude, that is Q by A, or all these things. Now the thing is that what is the electric field at this point, and what is the electric field at this point. Already we discussed this problem in our last lecture, that if I consider a point here, then the electric field direction due to positive charge is along this, and similarly for negative charge it will be along this. So net electric field will be 0, because due to a plate capacitor we know that the formula of the electric field is always sigma by twice epsilon naught. So similarly if you consider this point also, then electric field will get cancelled. Now at the point, the middle of the two plates, the electric field is non-zero, and the direction will be same, so the total electric field can be written as like this, sigma this twice epsilon naught, that will give you sigma by epsilon naught. So this is the total electric field inside the conductor. So now what is the capacitance? So you can see here, so this is the distance, between the capacitance, sorry, between the conductors, and this is the area. So how can I write now? You can see this is the E, so E can be written sigma by epsilon naught. So what is the value of sigma? The Q by A, just put this value here. So this is the electric field. Now if the potential difference between the plate is V, then what is the relation between V and E? So this is a distance D, so the relation between E and V can be written as like this, potential equal to E into D. Okay, so now E just put here, then substitute the value of D. There is no value of D, just you have to put the D. Then what is the capacity? Just use the formula Q by V. So this is the value of V, already we have calculated, just put here. So then you will get the capacitance of a parallel plate capacitor. Okay, now the most important thing is that inside the conductor there is a vacuum, there is no other medium. Now if I place some dielectric medium inside the plates, then the capacitance will be sensed, because capacitance directly depends on the nature of the material. Okay, so then you have to use a different concept. So here you can see here, when the plate of the capacitor are separated by dielectric medium. Okay, so this is the dielectric medium, suppose, and it has some relative permittivity like nu r, then C can be written as nu C can be written as, so here nu naught r, you cannot, like, so here you can see nu naught A by D. Okay, so that is, if you place a vacuum or air in between the conductor. Now if you place some dielectric medium, then what will be C? Then you cannot write epsilon naught, then you have to write the permeability. This, okay, so this is a permeability, and what is the relation? Nu naught nu r A. Okay, if you consider different medium. For air, we already mentioned that epsilon this equal to 1 for air or vacuum, so we can write like this. But in case of a different medium, different dielectric medium, then you have to write all these things. Now from this formula, one thing is clear, that what is the value of this mu naught d a, and that all these things. So this is can be written as C naught, or capacitance in the capacitance of a parallel plate capacitor. If we placed the conductor in a vacuum, that means their separation, the material which is placed between the conductor is vacuum. Now if we place a different dielectric medium, then we have to write C naught epsilon r. Okay, so epsilon r it can be written as, and that is C equal to C naught K, because this is the called dielectric constant. Okay, so that means in a defined medium, or if the conductor are placed in a dielectric medium, so if the separation between the conductor, if you place a dielectric medium inside the conductor, then what will be the capacitance? The capacitance will be the K times the capacitance of the conductor which is placed in a vacuum. Okay, so this is the relation, and that's all about the electrical capacitance of a parallel plate capacitor. Okay, and the thing is very conceptual, just you have to think very carefully that why I have used both the formulas. The most important thing is that inside the conductor what I have placed, if I place in the vacuum, then this is the formula, this is the final formula. Okay, if I place a dielectric medium between the conductor or between the parallel plate capacitor, then this will be the formula. Okay, so this is the formula, because it will depend on the material, nature of the material. So, and also it depends on the area and the separation distance. So it does not depend on the charge and potential, but it depends on the size and shape. Okay, so that's all about.